Hey everyone, welcome to Code Harmony. Today we are going to solve this question 2349. Design a number container system. This question falls into the design data structure category and based out of hash table. Also, this question has been asked in Google 3 times in the last 3 months. Let's have a look on the problem statement. In this problem, we have to design a number container system that can do the following. Insert or replace a number at a given index. One thing. The second one is return the smallest index of a given number in the system. Okay, this functionality we have to implement. They are also saying that implement a class where constructor is going to initialize the system and there is a change function. Change function is going to get an index and a number. So if any number is already present on that index, just replace that. If not, then place this new number. And the second function is find. Find taking a parameter as a number, and what it is returning the smallest index, because a number can be present on multiple indices. In that case we have to return the minimum index where the number is present, -1 otherwise. Let's try to understand it further with the help of this example. Here we are given, first of all, first query is number containers. It means initialize our system. Then a find query with the parameter 10. It means find 10. And what is that find function? Find function is going to return the index, smallest index of that number. If not, then return -1. So this query is going to return -1. What is the second query? Second query is the change query. Change query with the parameter 2, 10. It means at index 2 we have to put a value of 10. Great. At 2 there is nothing present on the 2 already. I'll just put 10. Next query is also change. At index 1 we have to put 10. Got it? This is something we have to do. And the next change query, what we have to do, this is the index, this is the value. Just go to the index and place this value. Next change query 5, 10. And what is the next query? Next query is find. Now find is something we are going to find the value and return the first index. What is the value here? This is the value. Find 10. Find 10 in this system and return the first index. So if I have to return the first index, if I just try to iterate over left to right, first index is going to be 1. So I'm going to return 1 from this. And the next query is change 1, 20. It means at 1 we have to replace the value. There is already one value present on 1, which is 10. Now the query is saying that 1 should have 20. In this case I am going to replace this value with 20. Okay, and now the next query is find query. Find the number 10. If I have to find the number 10, I will be saying the first index where 10 is present. That is 2 in this case. So this time it is going to return 2. And all of these are not returning anything because there is a void. This is not returning anything. This is also not returning anything because this is a constructor. Okay, so this much we have to do, right? Only this much we have to do. But if we have done this, then try to analyze the time and space complexity. See, what is the time and space complexity? Time is something when we are doing the change operation, we are not taking any extra time. When we are doing the find operation, we are iterating over it. So find operation is going to take order of n time. What about the space complexity? Space complexity is what is the size of this system. In this case I have taken an array and the index can go till 10 to the power 9. It means the array size will go till 10 to the power 9 plus 1. That is very big in number. And we are going to get memory limit exceeded in this case if I just initialize an array of this size. So space complexity is also order of n, but yeah, in this case it is not feasible to take an array. So we are not going to go with this approach. They are also saying that at most 10 to the power 5 calls will be made in total change to and find function. So if at most 10 to the power 5 calls are going to be made, it means we are going to have at most 10 to the power 5 entries in this system. If it is only 10 power 5 entries, there is no need to take 10 power 99 size array. No need to get memory limit exceeded. We'll just go ahead with the map. Okay, this we understood, that we have to take some kind of map that is going to take integer comma integer, and that map is going to be index to number map, standard index to number map, the standard alternative to this array. So in this case it is going to be 2, index 2 is going to have value 10, index 1 is going to have value 10, index 3 is going to have value 10, 5, 10, then index 1 is going to have a value of 20. This is replaced, so replaced with 20. This is my map. Using this map I am able to do this change operation. Change operation is fine. Now what about the find operation? Find operation was initially taking order of n time because we were doing linear iteration over this array. And now what we are going to do is, find operation is something finding a number. But in this map there is no number. There is only indices. This is index, and this is value. This value is the number. So for this we also require some kind of map type data structure, which is going to tell us that this number is present on how many indices. So this is the number 10, and number what we require is we require indices. So we should have a map which is going to get number as a key, and the indices are the values, and this indices are a list. If I just take a list, in this case we might have to iterate over the list, and it can go order of n, linear time. So can we do it in a better way? The first thought that can come to your mind, why not we just take a priority queue, because we require index which is the smallest, right? Let's say the 10 is present, and in this case 10 is present at 3 indices, 2, 3, 5. What we have to return is, we have to return the least index. If we try to keep it sorted, there are the chances that we might have to remove any index. If we have to remove any index, we have to do some operation. If we are only concerned about the least element, why not we just take a priority queue? Okay, this is the thought that can come to our mind, that why not we just take a priority queue, and the priority queue is going to give us the minimum value in the order of 1 time. Correct? So for the 10 I can maintain an entry which is going to have all the indices where 10 is present. 10 is present on 3, 2, 3 and 5. Okay, so when we are finding the value, this find operation is going to get order of 1 time, because find operation is just returning the minimum index. Now our approach has modified, because we are taking a 2 map. One map is for index to number map, and the second map is the index, which is number, to priority queue with integer, that is number to indices, number to indexes. So in our new approach we should analyze what is the time and space complexity. For the find operation is something for a number. Let's say the number is 10, just return the least index where the number is present. I can directly check this map, number to index map. Number to index, if the entry is present, the number is also present, and return the minimum index. It means the peak value of the priority queue. So find operation can be done in order of 1 time. And what about the change operation? Change operation is something, let's say this change operation is this one, change 1, 20. It means there was 10 value present at index 1, and now 20 value we have to insert at index 1. Something like this. Operation 10 will be replaced with 20. In this case, what we have to do? We have to update the value in the first map. That can be done in order of 1 time. And we have to remove the value from the second map, right? Because second map is something 10 is present at how many indices? Initially this was the state. Before this change function, this was the state. 10 was present at 1, 2, 3, 5. And now there is a need that 20 will be present at index index 1. Yeah, it means index 1 should be removed from this collection, which is the value of 10, right? So after this operation, 10 will be present at 2, 3, 5. So we have to remove 1 out of it. If we have to remove 1 out of it, removal in priority queue, how much operation does it take? In the worst case, it takes order of n time. Removal in priority queue takes order of n time. So the change operation, if I remove the item on the change, then it can go order of n time. But that is also not acceptable. So now, so far what we have understood is that when there is a find query, we are able to return the minimum index in order of 1 time because that is a priority queue. But if that is the case, on the change operation, we might take order of n time, because on the change operation, when the 10 was initially present at index 1 and 20 is going to be present at index 1 now, so this one entry should be removed from the second map, which is number to indexes map. And this operation can take order of n time, which is not affordable. We can do better. Priority queue is something, when we are inserting in a priority queue, then the time is log n, and we are polling a value that is order of 1, and the reheapify operation takes log n time. But deleting a value from the heap takes order of n time. What do we do to save this time? Order of n time. On the change operation, we are changing the value in the first map. Changing the value in the first map is not going to take any time. And now inserting, we were deleting the previous value and inserting the new value in the priority queue. Instead, we are not going to delete the previous value. We are going to keep it like this. We are not going to delete 1 from 10. We are just going to insert. These are the two operations. One should be deleted from 10 and one should be updated into 20. This is something we are not doing. Only this thing we are going to do. And in that case, what is going to be the time? Time is going to be log n, because insertion in heap is log n operation. If I am doing this, what will be the change operation time complexity? Change operation time complexity will be log of n. But in this case, find operation is not going to give me the updated index all the time, right? It is going to give me the least index, but that least index can be the stale index, because we are not deleting from the priority queue. Deletion operation is quite heavy. We are saving that. Instead, if we are not deleting, then we might be having some stale indexes in the priority queue. And for that, we are sure that removing the top of the priority queue, it means remove the minimum element of the priority queue. If that is a stale element, then just discard it, pick the another one, discard it, pick the another one. And that every operation is going to take log n time. Heapify operation is going to take log n time, and let's say k elements were there which were the stale indexes. It means those indexes are not correct. Got it? So let me try to dry run over this example. You will get more understanding. Copy and then paste. Okay, we are having two maps. Index to number map, number to indexes map. And this map is going to take integer and the priority queue of integer. And this map is going to take integer comma integer. Got it? First operation is number container, not doing anything. Second operation is find operation. Find value of 10. 10 is not present in this map, so we are directly going to return -1. Okay. Next operation is change operation. Change the value of second index, which is 10. This is not present. Inserting it for the first time. This entry is made, and in this map also we are going to put 10 is the number, and what is the index? Index is 2, and this 2 is inside the priority queue. Let's go to the next query. Next query is change the value at index 1 with value 10. Okay, this is something I did. The 10 value is already present. I'll just insert in that priority queue. Go to the next query. 3 is 10. 3 with value 10. 3 is also going to come in this priority queue. Next query is 5, 10. 5 with value 10. 5 is also going to come in this priority queue. Got it? Now the query is find query. Find query with value 10. Find the value of 10. It means find the first index where the value 10 is present. Okay. I'm just directly going to check this map, number to index, because I am having a number. So I'm going to this entry. Going to this entry is order of 1 time, and in this entry checking the priority queue, and checking the priority queue, getting the peak value, right? Peak value is something order of 1 time. Now I have decided in this approach that I'm not going to delete entries from the priority queue, because deletion is very heavy. So there might be the possibility that this peak index is not valid, or a stale value. We are not going to explicitly remove the entries from the priority queue. So here we are going to get the minimum. Minimum is 1. Now we will check at 1 whether the value is present which is equal to 10 or not. So at 10, yeah, actually the value 10 is present. So it means it's a valid value, and yeah, this is minimum because we are picking it from the priority queue. So just return 1 out of it. The value of this is going to be 1. Now let's move ahead and check our next query. Next query is change the value at 10 with the value 20. So value of 10 will be updated to 20. And after that there is a same call, find the value of 10. Find the value of 10. Now let me find the value of 10. In the 10, I am going to this priority queue, and I am going to pick the minimum value, which is 1. And I am check the value at 1. But at value at 1, the value is not 10. It means this is a stale entry. Just discard it and pick the next one. The next one is 2. At 2, yeah, 2, the value is definitely 10. So 2 is going to be my answer. So when we picked it and the heapify operation took place, that took log of n time. But in the worst case, if let's say we are removing k stale entries, so that will be k log n, and the overall time complexity will be k log n for the find operation, log n for the change operation, right? This is better than the change operation, which is going to take place order of n time. Okay, so this is our approach where we are utilizing to map integer comma integer and integer comma priority queue. But in this case we are not deleting the entry state forwardly, because deletion is going to take order of n time. So you have to make sure you are going to do lazy update in the priority queue. Got it? So this is our first approach using priority queue. Why I picked this approach? Because yeah, priority queue is the standard thing which definitely comes to our mind when we have to get the minimum index. So that was our first approach. Now we will be coming to our second approach, approach 2. Let's see what changes I'm going to make in this case. Here we definitely have to get this integer to number map, but instead of this priority queue, if I just take a set data structure, from this set just get to know what is the minimum value. For that we have to iterate over it, right? That is going to take order of n time. But instead if I just take a tree set. Now why the tree set is beneficial? Because the tree set is going to take a finding minimum or maximum is going to take order of 1 time, and all the other operation like removing, deletion, updation, and all the different kind of operation are going to take a log n time. So this is a tree set. So if that is the case, we can utilize the same approach to our previous example. So let's say this is the index to number map. Initially at one index the value was 10. Now I'm getting a query that 1 should be updated with value 20. Along with this there should be another map which is 10. Is going to have initially it was having a priority queue, now it is going to have a TreeSet which is 1. So in this case, if I just get a change query, change the value at index 1 with value 20, what I'm going to do? Firstly, I'm going to update it in the map and capture the old value. Old value is 10, and go to the old value and delete the index. Okay, if the index, after deleting the index there is no index left, then delete the row as well. Then update the next, add the next row or update the next row and add that index in that row. Okay, so this is the case. So here if I have to do the find operation and change operation, what is going to be the time complexity for that? Change operation, let's say first have a look on the change operation. In the change operation, firstly I updated this map order of 1 time. Updating this map, it means deleting a value and adding a value, that is log n time, right? So change operation is going to take log of n time, order of log of n. And what about the find operation? Find operation is going to take how much time? Find operation is something, let's say find 10. It means what is the least index where 10 is present. In this case, if I just make a call of find 20, that is going to give 1, and that is constant operation, order of 1. So if we use a sorted set, then the change operation time complexity is log of n and order of 1 for the find operation. I hope you understood the approach. If you get any doubt, you can comment down below. Now let's have a look on the code. I have taken two maps. First one is my standard map, index to number. The second map is value and index map. This is the value, and this value is present at these many indices, and these indices are a part of TreeSet. It means finding the minimum index, finding the maximum index is going to take constant operation, and all the other operations are going to take log n time. Initializing them in the constructor, and let's firstly come to the find operation. Find operation is something, finding the minimum value. Value index map. If the entry is not present in value index map, entry is not at all there, return the -1, otherwise return the first value from the map, that is the minimum one. Now comes the and what is the time complexity of this find operation? That is order of 1 time. And now we come to the change operation. Change operation is going to take log n time because of this TreeSet. What we are going to do in this change operation? When we are getting a change request, index with value, there are two options, whether there is already a value present on that index or the value is not present at that index. If the value is not present at that index, just put the value, and put the value in the value map as well. Okay, putting a value means map.put index.number, and putting a value in the value index map, it means if it is not initialized, just initialize with the new TreeSet and add that value. Adding value in the TreeSet is a common one, so I have kept it outside of the loop. Otherwise, the second option is we have to replace the value. To replace the value, we need to know the previous value. Previous value at that index is old number. Now we have captured that, update it, no worries. Now with the old number, remove the entry of this index from the TreeSet. Value index dot get old number dot remove this index. And now why this statement? It means if for the old number the entry is not having any index, then there is no need to keep that entry. Remove that entry as well, because that check is being used here. Okay, so this is the code for this approach, taking log n time for the change operation or 1 time for the find operation. This is the best approach, and now I'm going to submit this code. This is working fine. In case you have any doubt, you can comment down below. Thank you guys, bye bye.